So whenever I see a question like this in Stack Overflow, like what is the difference between a var and a val definition in Scala? Our Scala traits compiled into Java bytecode. What's the ease and cost of Scala's lazy val? And so on. I like to take a look into the bytecode and understand what is happening under the hood. So the goal of my talk today is to give you the tools to be able to do it yourself. And we're not going to cover all of these questions, but at the end of the talk, you'll have all you need to take it into the next level. The talk consists of two parts. The first will focus on some JVM basics, and then we'll be able to move to the cool stuff. All right. So how many of you are familiar with the term bytecode? All right. How many of you ever seen a piece of bytecode? Okay. And was it, last question, was it a bytecode that originated from Scala code? Okay, okay. Pretty good. So just to make sure we are all aligned, this is the definition from Wikipedia. Java bytecode is the instruction set of the Java virtual machine. And since Scala ran on the JVM, Scala code compiled into Java bytecode. And then the JVM know how to translate these instructions into the specific processor calls in order to execute the bytecode on the specific machine. And bytecode are stored in class file, which are files with the .class extension that can be executed by the JVM. So we basically start with some source file with the .scala extension. We then compile it using the Scala C command, which results in a class that has the in a file that has the .class extension that contains bytecode. And finally, we can use Scala to run it using a Java runtime environment. Now, if we want to explore our class file, we have the JavaP command. So JavaP is a command line tool that comes together with the JDK, and it can disassemble class files. And using it without any parameters will print only public members and method of the class. So here, for example, the example class had 3 public methods. We can use it also with a -p, and it will print also private members and methods. So now you can see that the example class has 2 private members, and then it has a few methods. Some of them are private, and some of them are public. And the last option we need for this talk is the -c, which prints the disassembled bytecode. So here you can see the bytecode of some of the method of the example class. There are a few more options. This is all I used for the purpose of this talk. All right, so let's take a quick look into the JVM. This is our JVM. It has a few threads, at least one. And when a new thread is created along with a stack that aims to hold method frames. And when a method is invoked, a new frame is created on top of the stack and discarded once the method is finished. Now let's zoom in into a single frame. So each frame holds 2 main structures. The first one is the local variable tables, which hold all the method locales, including arguments. And if the method belongs to an instance, then in the first cell will hold the value of this. And the second structure is the operand stack, which is different from the thread stack from the previous slide. It is empty at the beginning of the method, and the JVM uses it in order to execute the bytecode. So let's see how does it work. We have this add method that gets 2 integers, a and b, and returns their sum. And when I use JavaP with the C flag, I got the bytecode of the method. And now let's assume that the method was invoked with 2 and 5 as parameters. So this is our frame. The local variable is of length of 2. It holds the values of a and b, which are 2 and 5, respectively. And the first command I load the value from the 0th, from the element in the 0th place into the stack. So it pushed the value of A, which is 2, into the stack. The second command, iload1, do the same with the element in the first place. So it takes the value of B, which is 5, and push it into the stack. The next command, iadd, pops the 2 elements, sums them, and then push the result back to the stack. And finally, iReturn simply returns the top element from the stack as the result of the method. The frame is discarded, and the result is being pushed to the operand stack of the invoker frame. All right, so this is all the basics we need for the rest of the talk. Now let's move to the cool stuff. So we'll start with the very basics, the actual difference between val, var, and def. So here I wrote 3 classes, val, var, and def. Each of them holds a member A that equals to 1, and the only difference is the type of A, which is val, var, and def. Now I use JavaP to print the methods and members, and this is what I got. So the first thing we can see is that both val and var has a private integer A. We can see that it is final for val, which makes sense and corresponds to the immutability of a val. Next, we see that all 3 classes has a public A method that returns an integer. And let's take a look into this method. So val and var, the A method of val and var is exactly the same, and it is different for def. Can anyone guess what is the first method is? No? All right, let's see. Okay, so the first command, load the value of this into the stack. Get field, pop the element from the stack, and access a field called A, like you can see here. So it accesses a field of this, and it pushed this value back into the stack. And I return this value as the result of the method. So this bytecode is equivalent to doing following. So this is a classic getter method. I didn't wrote it, as you saw before. The compiler generated it for free. And for def, we see that the first command, iconst1, push a constant of 1 into the stack, and I return it as the result of the method. So this is equivalent to simply return 1, which is the method that I wrote. I wrote def A equals 1, so it is my original A method. All right, so now var has a unique method called $$EQ that gets an integer. Let's see what is it. So load0 load the value of the element in the 0th place into the stack. So it push this into the stack. iload1 push A into the stack. A is the argument of the method, is the integer argument. Put field pops the 2 elements and set the value of the field A of the first element to be equal to the second element, and that's it. So this is equivalent to doing this that A equals A, which is a standard setter. Again, the compiler generated it for free. And finally, let's take a look at the constructors of the 3 classes. So val and var again shared the similar constructor, and def has a different one. The first thing that happened here, since Java requires every constructor to call its parent constructor before performing any self-initialization, so both constructors first call to the parent constructor, which is the constructor of the object. You will see it a few more times later. I will only speak about it once. The next thing that happened here is first load0 load this into the stack. I_1 push a constant of 1 into the stack, put field, pop the 2 elements, and set the field A of this to be equals to 1. So this is equals to this.A equals 1. And this is the initialization, okay? This is the code that I actually wrote in the classes. And for def, nothing is happening. We simply return. So to summarize, when we use val and var, the Scala compilers generate for us a standard getter. When we use a var, we also get a setter method. And the big difference maybe between val and var to def is that the evaluation happened only once for val and var, but for def it happens multiple times. Essentially, every time we invoke the method, the evaluation happen again. All right, so let's move to a bit more complicated example, lazy val. So this is the val class from before, and now I added another class called lazy val, and the only difference is that I add the lazy keyword. As we know, it ensures that the value will be evaluated only once it's really needed. Okay, so again, I use Java P, and this is what I got. So both classes has a private member A. We already saw that it is final for val. And for lazy val, it is not final. It makes sense because if it was final, it should have been initialized either in the declaration or in the constructor. But this is lazy, so it might needed to be initialized later. Let's look. We already know that the constructor of val initialized the value of A to be 1. We saw it before. So the constructor of lazy val, as you can see, again, it calls to the super first, and then it simply returns. It is very similar to the constructor of def we saw before. So it's really don't do much. And now we can see something interesting. We have here a volatile Boolean bitmap $0, and we also have a private method a $lazy compute, which I never declared, obviously. And let's see what it is all about. So this is the bytecode of a $lazy compute. And the first thing that's happening here is that the thread trying to gain a lock and to start a synchronization block. Once it's succeeded, we can move to the heart of the method. So first, there is a compression between the bitmap 0 to a 0. And if it is equal to 0, a few things happen. First, we initialized A to be 1. Second, bitmap 0 is set to be 1. And then the lock is released. And finally, the method returns this.a. So basically, bitmap 0 tell us if A was already initialized or not. And since it is 0, A wasn't initialized yet, so it is being initialized, bitmap set to 1, and that's it. And we can return the value of A. If it was 1, so we know that A was already initialized, so we simply release the lock and return the value of A. And this is equivalent to the following Java code. So there is this synchronization block, and then there is this part when we check if bitmap is true or false, and if it's false, we initialize both A and bitmap, and then we can return it. Okay, and last thing, we already saw that for val, the method A is a simple getter. Let's take a look at the A method of lazy val. So again, the first thing that happened is a comparison between bitmap 0 to 0. And If it is 0, we know that A wasn't initialized, so there is a call to the method aLazyCompute that initialized A and returns the value of A, if you remember. And then we return the value that was returned by aLazyCompute. And if bitmap 0 was 1, we know that A is initialized, so we can simply return it. So to summarize, the main difference is where the evaluation of the value is happening. For a val, we saw that it is happened in the constructor of the class, and for lazy val, it happened in the lazyCompute method that is being called when we try to access the value the first time using the method A. And it is important to notice that basically since we are using the synchronization block, so the implementation is thread safe, and it's also very efficient because the synchronization block is only happened when we try to evaluate the value in the first time. But after that, we always check the value of bitmap. So the lazyCompute method is only being invoked at the first, when we try to evaluate it the first time. All right, so let's talk a bit about object. And object is a notion of Scala, so let's see how it is translated into a first-class Java citizen. All right, so this is my hello object. It has a simple main method, and it's print hello Scala swarm. And I saved it in a file called hello.scala. And when I compiled it, I got two files. The first is hello.class, and the second was hello $.class. So let's see what is happening here. All right, so the first thing we can see is that both classes was compiled from the hello.scala class. Okay. Next, the hello class has a static main method. Let's see if this is my main method. So the first command get static push this field hello $.module into the stack. We will see what this field in a moment. aLoad0 load, since this is a static method, so the first place doesn't hold the value of this. So it simply holds the value of the first locale of the method, which is the argument. So aLoad0 load args into the stack, invoke virtual, then pop the two elements, and invoke the main method of the first element with the second element as its argument. And that's it. So this is equivalent to doing the following: hello $.module $.main with args. Let's see what this is. So this is the module $. We just saw. It is a field of the hello $. Class. It is a static field, and its type is hello $. And to understand what it holds, we need to continue, and we'll start with static block here. So in the static block, the first thing that happened is the new command, which push a new instance of the hello $. Into the stack, and it is not initialized yet, just a new instance. Then invoke spatial that call here to the constructor of hello $. So it popped the element and called the constructor. So now this instance is initialized, and that's it. So it is equivalent to doing the following. And let's take a look at this constructor. And as you can see, it is a private constructor. So again, at the beginning, there is a call to the parent constructor, but then aLoad0 push this into the stack and put static, set the value of the static field module $, to be equals to this. So this is similar to doing the following. So you saw that in the static method, we created a new instance of the hello $sign and initialized it, and now we are setting it to be the value of module $sign. And finally, there is a main method here. Maybe this is my original main method. Let's see, get static, push this thing, predef $sign dot module $sign into the stack. Predef basically brings a bunch of things that are very useful without the need to mention them explicitly. And it is here, so we can use in a moment the print line method. LDC, push the string hello Scala swarm into the stack. Invoke virtual, pop the two elements, and it's called the print line method of predef module with the second element, hello Scala swarm, as argument. And that's it. So this is basically the code that's happening here. All right, so to summarize, we first start with to call the main method of the hello class, which call to the main method of the module field, but in the first time we need to start by initializing, by running the code in the static block. So we start by calling the constructor of hello $sign. In the constructor, we set the value of module $sign to hold this instance. So now module $sign is initialized, and the main method can be called at this moment and print hello Scala swarm. So to summarize what we saw, given a problem like some weird behavior that you don't understand, or if you wrote some code and you expect it to behave in some way, but it didn't, consider the following steps. First, use JavaP. Second, repeat. And that's it. If you have any questions, I'll be happy to try and answer.
Okay, so we have some questions.
Yeah, hello, thank you for the talk. Can we go back to the slide with var, val, and def?
Yeah. This is long.
I think the implementation of int a.
Okay. So here it is.
Yeah, and I just wondering how getting this information from JavaP I can understand the performance issues, because what I see here is the implementation for def is shorter, and it's also shorter in the constructor. It looks like this is more efficient way.
This is more efficient way to do what? Sorry?
To return one.
Like the implementation of def? Or, yeah? So, yes, okay. So for the actual difference is that you can access A of def a few times, and you, so this code will run again and again every time you access it. And in the first case, it will set once, but then anytime you access it, it will simply return the value that. So okay. So I understand you are asking, like, why not doing simply icons 1? Yeah, in A. That's a question to the.